Okay, so in this lecture, we are going to start projection of lamina. So firstly, you have to understand what is a lamina. Actually, lamina or surface or area, both the names are same. Actually, by the example I can give you, lamina, that a piece of paper. Okay, the paper has got two dimensions, so there is no third dimension is there. So it can be said as a lamina. So piece of paper can be said as a lamina. So here in the first case, see for the first case, follow my cursor. In the first case, it is vertical plane and it is horizontal plane. So a square lamina, isn't it, a piece of paper? The piece of paper is cut as a shape of a square. So it has become a square lamina, ABCD. So ABCD square lamina is placed in between VP and HP in a manner that is the plane of the lamina is perpendicular to both HP and VP, isn't it? For this particular case, the plane of the paper is perpendicular to both VP and HP. So now if we want to draw the projection, we have learned in our previous lecture that how to draw a projection that the shadow appear on the vertical plane will have to be drawn on the above to the ground line, and below to the ground line you have to draw the shadow on the horizontal plane. So VT and HT means vertical trace and horizontal trace. When the lamina is appearing as a line in which view, that view is called trace, TRAC. Okay, so it is vertical trace and it is lamina horizontal trace. So as this lamina is appearing as a line in both VP and HP, so it is being called as trace, vertical trace as it is in the vertical plane, and horizontal trace as it is on the horizontal plane. Okay, so this is for the square lamina. Now here, let us see the second example. It is a triangular lamina. Okay, so the triangular lamina is placed in a manner that the plane of the lamina is parallel to the vertical plane and perpendicular to the horizontal plane, isn't it? Parallel to the vertical plane and perpendicular to the horizontal plane. So as the plane is parallel to the vertical plane, so the true shape of the triangle, isn't it? We have already learned when we are doing the projection of a line, that when the line is parallel to particular plane, the true shape or the true length of the line will be obtained in that plane. So as that lamina surface of the lamina is parallel to the vertical plane, so that on the shadow on the vertical plane will be true shape. So no VT means no vertical trace, as it is not appearing as a line, so no VT. But in the horizontal plane, it is appearing as a line, isn't it? So as a line it is appearing as, so it will be appearing as a line in the horizontal plane and appearing as a true shape of the triangle in the vertical plane. Why it is called parallel? I am repeating again, because all the points on the surfaces of the lamina are at equal distance from the vertical plane. That's why it is parallel to the vertical plane. Now for this case, the square lamina is placed like that. It is parallel to the horizontal plane and it is perpendicular to the vertical plane. Okay, so as it is perpendicular to the vertical plane, so it will be appearing as a line in the vertical plane, and as it is parallel to the horizontal plane, so true shape of the square will be obtained here at the horizontal plane. So no HT, no horizontal trace, as it is not appearing as a line in the horizontal plane, so no horizontal trace, but a vertical trace will be there, isn't it? Now let us come to this example. So that square is now making at an angle. Okay, it is making at an angle with the, what can I say, that vertical plane. Okay, and it is still perpendicular to the horizontal plane, so it will be appearing as a trace, isn't it? And the true shape of the square will not be obtained in the vertical plane, isn't it? And it is the side view. It is the side view. So vertical trace will be available at the side view, at a plane. It's not actually side view. So at a plane which is perpendicular to the plane. So this is a auxiliary plane. Actually, we are going to discuss about auxiliary plane to draw the side view, while we will draw the projection of solids. But for the time being, just understand this, that this plane is not parallel to the vertical plane, so true shape of the square will not be obtained here. So a reduced shape of the square will be obtained here, isn't it? And a horizontal trace will be there at a particular angle. So angle has been drawn here at an angle phi. Okay. Now, for that case, the plane is perpendicular to the vertical plane and it is inclined to horizontal plane, isn't it? So again, I am saying that in the top view or in the horizontal plane here, the true shape will not be obtained, isn't it? True shape will not be obtained. And here at the vertical plane, it will be viewed as a line. So it is vertical trace. So this is the basic concept of the laminar projection. Now let us move to the problems now. So it is the first problem. A regular pentagon of 25 mm side has one side on its ground. That means one side will be on the ground. Ground means on the ground plane, or actually on the horizontal plane. Ground means by the term ground, we will know that it will be on the horizontal plane. The plane is inclined at 45 degree to the HP and perpendicular to the VP. Draw its projection and show its traces. Okay, so it is just like this one, isn't it? The shape is so only the pentagon will have to be there. But if we compare that, if we want to compare the orientation of the pentagon, it will be like that. So again, in the top view, the true shape will not be obtained, isn't it? So this is the final view. We have to draw the initial figure first, to then have to come to the final view. Now, how it is drawn? Please hear me out. That okay. So, firstly, the reduced shape of the pentagon cannot be drawn, isn't it? Because we don't know how much length will be reduced. So what we have to do, we have to draw the full shape of the triangle. Okay, so A, B, C, D and E. So I am repeating the process how it is being done. You have to draw a perpendicular line first, perpendicular line of 25 mm length. Okay, then you need to draw 108 degree angle, 108 degree at one side and at other side also. So now you have to mark that 25 mm of AB and ED is also 25 mm. Now making center at D, you have to draw an arc of 25 mm radius, and making center at B, you need to draw another arc. So those two arcs will meet at point C. If you join DC and BC, then the whole pentagon will be obtained. Okay. And after drawing the pentagon, what you need to do that you need to draw perpendicular lines, as I have already told you during the line projection. These are called projection lines. Okay, so these will be thin lines. So from D and also from E, so 3 lines will have to be drawn. Okay, 3 lines will have to be drawn. So A dash. So if we see view from here, so name of that point will be A dash E dash, as both points are coinciding each other. So name of that point, only A dash has been written here, but you have to write here. Please hear me out. That A dash, comma E dash. Okay. The next point will be here. So each point is B dash, comma D dash, and name of that point will be C dash. Okay. Name of that point will be C dash. Now what we have to do now, at the next view, draw the same length of line, okay, like from A dash to C dash line at an angle of 45 degree. Okay, so at the second stage, what we have to do, we have to draw a line. We have to draw the same length of line which has just been obtained at an angle of 45 degree. Okay, the same line is being drawn at an angle of 45 degree. Okay, so now with the now take the pencil compass and take the measurement between A and B. Okay, A and B, take the measurement and cut it here. C has already been marked, so I have to mark the point B only. Okay, so 3 points are being marked: A dash, B dash and C dash. So the name will be A dash, comma E dash actually, and B dash, comma D dash. So A dash, comma E dash, B dash, comma D dash and C dash. So after obtaining these three lines, we need to draw perpendicular lines, okay, from all the points. From A, perpendicular line, from B, perpendicular line, and from C also perpendicular line, okay. The perpendicular lines are drawn, and from this view, we need to draw perpendicular lines also. Through C, a perpendicular line is drawn. Through D, a perpendicular line is drawn. We don't know the length. Actually, these two points will meet at here. And from B also, we need to draw a perpendicular line. And from A also, a perpendicular line is drawn. So from all the points A, B, C, D, and E also, we need to draw perpendicular lines. And E will intersect at E. So as this point is E, so A dash comma E dash. So projection from E and projection from B will meet at E1. Again projection from A and projection from A, so it is A1. Then B and B also, this is B1. So that point will also be D. So projection from D and projection from D, this is D1. And projection from C and projection from C, so the C1 point will be obtained. Now if you join those points with the dark line, then A1, B1, C1, D1, E1. So that reduced shape of the pentagon will be obtained. So you don't need to draw this shape here. In the book, it is drawn here again, but you don't need to draw that pentagon, reduced shape pentagon here, or the inclined line here. That inclined line will have to be drawn here, and the reduced shape of pentagon will have to be drawn here. The process I have just told you. Now the next one here. So analogous to this, the figure is here, okay. So horizontal trace will be available, and so that shape of the reduced shape of the square is obtained here, but here it is not square. Here it is a circular lamina. So circle will be obtained as the ellipse, okay. So analogous to this, the problem is this. Now let us see what is being written here. Draw the projections of a circle of 50 mm diameter having its plane vertical. Vertical means is perpendicular to the horizontal plane, and inclined at 30 degree to the vertical plane, okay. Its center is 30 mm above the HP and 20 mm in front of VP. So it's traces, okay. Now, so it is said that the diameter is 50 mm of the circle, and it is 30 mm above the HP, okay. So first you need to draw a horizontal line, ground line actually, ground line, and then you have to take the center of the circle 30 mm above, okay, 30 mm above that horizontal line. You need to take the center of the circle. So actually, firstly you have to draw a horizontal line, a thin horizontal line, and on that horizontal line, mark that center and draw the circle with 50 mm diameter or 25 mm radius. So in the pencil compass, you have to take the radius of 25 mm and have to draw the circle, okay, and have to draw the circle. So once the circle is drawn, okay, once the circle is drawn, you need to divide the circumference of the circle into 12 equal parts, okay. So how it is done? Firstly, horizontal and vertical axis you can draw easily. Now, at 30 degree angles, you can draw lines, okay. So they are drawn at 30 degree, they are inclined at 30 degree with each other, the inclined lines. Now give names like that, 1 dash, 2 dash, 3 dash, as front view has been named as dash. Here the full name is not given, but you have to give names to all. 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, and 12 dash. Now through all the points you need to draw vertical lines. From 1 dash, a vertical line is drawn. The length is still, it's okay. The length is up to 20 mm, okay. As it is said that center is 30 mm above the HP and 20 mm in front of VP. So in front of VP, that means 20 mm below the 20 mm below the ground line. You need to draw a horizontal line, okay. A faint thin horizontal line will have to be drawn, and then up to that horizontal line, draw lines from all the points. From 1 dash to 2 and 12 will lie on the same vertical line. Then 3 and 11 will lie on same vertical line. 4, 10 already have lied on same vertical line. Then 5 and 8, 9. Okay, then 6 and 8, then 7. So you have to make dark only this portion. Okay, so this portion only you have to make dark. Otherwise, all the projection lines are thin. Okay. Now, what is said that its plane is vertical and inclined at 30 degree to the VP. Okay, so at the next stage, just to extend the line, we have extended already that line. Okay, so that center is always 20 mm below. Okay, so you have to mark here. So that line has been extended. So take a point here. Take the center at 20 mm away. 20 mm away from the XY line. Okay, and draw a line through that O at 30 degree. Okay, draw an inclined line through O at 30 degree inclined. Okay, so once the 30 degree inclined line is drawn, so O point is marked. So on that line, I have to mark the remaining points. So now take O25, the measurement O25, cut here O25, then O27, O26 actually, then O26, then O27, O27, then at the other side, take O3, O3. Now take the measurement with pencil composite divider, O22, so O22, and take the measurement of O21, mark here O21. Okay, so hence 1, 2, 3, 4 up to 12, all the points are found. Now what we have to do, through 4, so through all the points, we have drawn vertical lines, isn't it? Now, through all the points, we need to draw horizontal lines. So 4, so 3 and 5 will lie on the same line, and 2, 4, 5, 6, 2 and 6 will lie on the same line. 1 and 7 has already been lied on the same line. So 12 and 8, then 11 and 9 and 10. And through all the points, we have to draw the vertical line. So 1, from 2, from 3, from 4, from 5, from 6, from 7. Now you see, just like here, number of points are less here, only 5, but number of points will be 12 here. Now 4, 4, so you have to mark 4, 1. Then projection from 3 and projection from 3 here, so 3, 1. Okay, like that. So 5, and again this point is 5, so 5 will be here. So from that, you have to locate all the points, and then you have to join all the points by means of a French curve or freehand. So if you join those points, now the elliptical shape will be obtained. Okay, so that's how this is found. And another one, here it is the inclined with both the planes. Okay, so it is inclined with horizontal plane, it is inclined with vertical plane, and in this case, this hexagonal lamina is inclined with both the planes. So draw the projections of a regular hexagon of 25 mm side, having one of its sides in the HP and inclined at 60 degree to the VP, and its surface is making at an angle of 45 degree to the HP. Okay, so inclined with HP is given, inclined with VP is given 60 degree, and with HP also given 45 degree. So we have to make the simultaneous angle. But simultaneous angle, this figure cannot be drawn at first. So we have to move step by step. Firstly, we have to incline the plane with horizontal plane. Then we'll have to be inclined with the horizontal plane, vertical plane. Then that combined shape will be drawn here. So firstly, you need to draw the hexagon here. Okay, as I have already told you how to draw a hexagon, you can draw a circle, and inside the circle you can draw a hexagon. Otherwise, you can draw 120 degree angles. Okay, so firstly you have to draw a vertical line, and from that vertical line, 120 degree at one side, 120 degree at other side. This can also be drawn with the 60 degree set square also. Or if you find it difficult, then draw a circle, as I have already told you how to draw a hexagon inside a circle. Please follow that method. That is more easier than that of the angle. Okay, so you can draw that inside the circle also. So once you have drawn the hexagon, name that A, B, C, D, and E. So now draw vertical line. So up to that, to draw a ground line first. Actually, the length between the plane and the ground line has not been given. So just make a small gap, keep a small gap, and draw the horizontal line after drawing that hexagon. Okay. So now draw projection lines. Okay, so B and E will coincide, and C and D will coincide, and A and F will coincide. So that name of that point is A dash comma F dash. Okay. So that point is, so firstly B will come, then E. So B dash comma E dash, and C comma D. So C dash comma D dash. So this is the first step. And on the second step, you have to draw the same length line, that is A dash to C dash line, at an angle of 45 degree, and taking the measurement of A dash to B dash by means of a divider or pencil compass, mark that B dash point here. Okay. So now through all the 3 points, draw perpendicular lines, projection lines, and through all the 6 points, draw parallel lines or horizontal lines. Okay. So those points will meet. So A, projection from A, projection from A, so A1 is found. Projection from B, B1 is found. From C, C1 is found. So D point is here also. So D1 is found. Then E, this is also E. So E1 is found. So A and F, and F is here. So F1 is found. If you join all the points starting from A1 up to F1, then the reduced shape of the hexagon will be obtained. So this is the second step, where the inclination with that horizontal plane has been made. Now you have to make another angle, that is inclination with the vertical plane. It is 60 degree given. Okay, so what is needed to be done? That you have to draw a line first. Okay, at an angle of 60 degree. Please hear me out first. You have to draw a line at 60 degree with the ground line, as is given here. So 60 degree with the ground line, you need to draw a inclined line first. Okay, now take the length A1 and F1 with the pencil compass and mark it here. Okay, so through A1 and F1, 2 points are marked, A1 and F1. Now what you have to do, now see, so we need to find the remaining points. So how it is found, see now. So with that line, you need to draw a perpendicular line through F1. Okay, perpendicular line through F1, as through F1 a perpendicular line is drawn. So perpendicular line to the vertical line, isn't it? So F1 D1 line is perpendicular to the vertical line, and also A1 C1 is perpendicular to the vertical line. So the vertical line has become inclined to 60 degree line. Now with that 60 degree inclined line, you need to draw 2 perpendicular lines. Okay, through F1 a perpendicular line, and through A1 another perpendicular line. Now with the pencil compass, take the measurement between F1 and D1 and mark the point here. Also take the measurement of A1 and C1 and mark the point here. Okay, so that's how D1 and C1 are marked. So we have marked only 2 points. Now what you have to do, so this line is equal to this line here, isn't it? So now take the measurement here. Just follow my cursor from this to this. Okay, so mark a point here. Now through that point, draw a perpendicular line. Draw a perpendicular line again, and take the measurement from this point to this point and mark the point here. So hence you will find E1. If you extend A1 beyond this, you have to extend A1 beyond this. So mark that distance, take the distance and mark it here also, and through that point to this point, draw a perpendicular line. So let us say this point is here. So through this point you need to draw a perpendicular line and take the measurement from this point to the B1, same as E1, same as the E1 has been found, same the B1 will have to be found that. So take the measurement, so B1 will be found. Now we have found all the A1 up to E1. now join with that thick line, so you will obtain A1 up to F1. Okay, so once they are found, now draw horizontal lines from here, these 3 points, and vertical lines from these 6 points. Okay, so all the points will meet. So A1, A, so it will be on the horizontal line. F will be on the horizontal line, so AF is found. Now B, through B, draw a vertical line, and through B, so those will intersect with B1 dash. Next, so B and E is on the same line, same point, so draw a horizontal line, and through E, draw a vertical line, so E1 dash will be found. Now D1, draw a perpendicular line, CD is the same point, so draw a horizontal line, so D1 is found. So after finding all the points, draw them with thick lines. So A1 dash, B1 dash, C1 dash, D1 dash, E1 dash, and F1 dash. After finding all the points, you need to join the points with straight lines. So hence that reduced shape of the hexagon, which is inclined to both VP and HP, has been found.